Right, here's a good question. And if I take a look and do the same thing that we've done before, where I say, okay, what's P1, V1, T1, N1, P2, V2, T2, N2, and just from the information given, let's look at that. So what volume is 66 grams? So from the grams, I can get moles. Maybe let's just do that now. Um, Moles is equal to mass over molar mass. So the mass is 66 grams. The molar mass of nitrogen would be 28.02 grams per mole because nitrogen is 14.01 and there's two of them, right? Okay, so the moles you divide, that's going to be 2 point something or other. I'll figure that out in the calculator in a second. So that's how many moles I have, 2 point something. And then it says what volume, okay, will this gas occupy at STP? Well, I know that STP is standard temperature and pressure. The standard temperature is, what was that standard temperature? Just a second. All right, standard temperature was 273.15 Kelvin. Standard pressure was 100.0 kilopascals. So the initial temperature is 273.15 Kelvin, and the standard pressure is 100.0 kilopascals. So this question is a little odd because it doesn't give you, nor does it ask any final pressure, volume, temperature, or number of moles. So I'm actually just looking at information about a particular gas. And we can do that when we combine all the properties of or the conditions of a gas. If I know all of them, I can, or all but one, I can figure out the last one. And the formula to do that is PV is equal to NR and T, where P is pressure, V is volume, N is number of moles, R is a universal gas constant. We'll get to that in a second. And T, of course, is temperature. And I have all that information here except for R, but R is an unknown. So I'm looking for volume and I know everything else. So the volume is equal to nRT divided by P. So volume is equal to the number of moles will be 2 point. Why don't we figure that out now? Okay. That's a nice calculator. Just a minute. I'll put this over here somewhere. Sorry, that looks to be like a little bit of math stuff. Okay, I want to go 66 divided by 28.02. So 2.355. 2.355 moles. Let me just put that in the other spots too. Okay. And then I'm going to have to multiply that by the universal gas constant, which is 8.3145 kilopascal liters per Kelvin mole. Sort of funny units on that one. Times the temperature, 273.15 Kelvin, divided by the pressure, which is 100.0 kilopascals. So notice when we cancel, kilopascals go, moles go, kelvins go, and we wind up with liters, which when we're measuring volume is what we want to have. Okay, so let's do our multiplication here. So 2.355. I probably should have kept more numbers in my calculator for that. Let me just go back and do that. There. Oh, there it is. And this is worth mentioning how to do that. So it's 66 divided 28.02, that's my moles, and it's 2.355. So times 8.3145 times 273.15, good, divided by 100. Yeah, good. So there's my number, 53.494999. 53.49499 liters. And so if I round that to the appropriate sig figs, I've got 2 in the question, so I can just go to 2. So it'd be 53 liters. It's close to 54, eh? But this would have to be 50 for me to round it up to 54. So I leave it at 53. Okay, hopefully that helps you with that question.